In this video, I am going to discuss about the next topic, which is combination of capacitor. And in the combination of capacitor, first I am taking here series combination, means when the capacitors are joined in series. So in series combination. In series combination, the plate of the capacitor are joined alternately. It means second plate of first capacitor be connected to the first plate of the second capacitor, and second plate of the second capacitor be connected to the first plate of the third capacitor, and so on. And finally, the last plate or the second plate of the last capacitor be being earth, and first plate of first capacitor be connected through the source, like here C1, C2, C3 with three capacitor be joined in series between A and B. And first plate of the first capacitor, suppose this one be connected through a source, and this last means second plate of the last capacitor be being earth. So in this way you can say here, when the first plate of this first capacitor be connected to the source, so the source will give this positive charge. Due to induction, inner surface of it will get what here, negative charge, but outer surface positive charge. That positive charge will transfer here, whole here, and again due to induction of this positive, inner surface will carry negative charge, outer surface positive. That positive charge is transferred to the first plate of the third capacitor, and due to induction of this positive, again in negative, same amount of the negative charge be developed here, and negative charge, and here positive charge, and that positive charge is being earth. So in this way you can say, in series combination of the capacitor, the charge on each capacitor be same, while the potential difference across each capacitor will be different. Let C1, C2, C3 be the three capacitor joined in series between point A and B. It means C1, C2, C3 with three capacitors joined in series between the point A and B. And remember this, in series combination of the capacitor, the charge on each capacitor will be same, while the potential difference across each capacitor will be different. It means the charge on each capacitor will same here Q, while the potential difference across each capacitor will be different. Let the potential difference across the first capacitor is V1, potential difference across second capacitor is V2, and potential difference across third capacitor is V3, and potential difference across AB is V. So this V is equal to, since V1, V2, V3 be the potential difference across each capacitor which is connected between the point A and B, and the potential difference between A and B is V. So now you can say here कि V is equal to, now we can write V is equal to V1 plus V2 plus V3. Suppose this is question number 1, where V is the potential difference across point AB, and V1, V2, V3 be the potential difference across each capacitor. But now you see here, first capacitor, charge on the capacitor is Q, capacitance is C1, and potential difference across this plate is V1. So for first capacitor, for first capacitor, we can write, Q is equal to CV. So for this first capacitor, we can write here Q is equal to C1 V1, or V1 is equal to Q upon C1. Similarly, for second capacitor, Q is equal to C2 V2. Why? Because the charge is remains same, capacitance C2, potential difference is V2. So Q is equal to C2 V2, or V2 is equal to Q upon C2. And for third capacitor, Q is equal to C3 V3 R. V3 is equal to Q upon C3. Now, at the place of V1, V2, V3, we can write Q upon C1, Q upon C2, Q upon C3. Now, if these three capacitors C1, C2, C3 be replaced by a single capacitor of its equivalent value, it means at the place of C1, C2, C3, I am going to put a single capacitor of the equivalent value of these three. So now you can see here, it comes like this. Suppose its capacitance is like this one. This point is A and this point is B. Potential difference across this one is V, and suppose its equivalent is C equivalent, and here charge plus Q and this charge is minus Q. It means if at the place of C1, C2, C3, when we put a single capacitor of its equivalent value, then we can write here Q is equal to C equivalent into V, or V is equal to Q upon C equivalent. Now from equation 1 in this one, at place of V, now we can write Q upon C equivalent. So Q upon C equivalent, from here at place of V, we write Q upon C equivalent, which is equal to Q upon C1 plus Q upon C2 plus Q upon C3. Or we can write here Q upon C equivalent is equal to, take Q common, here 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now this Q is cancelled by Q, and finally we can write here the equivalent capacitance 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. It means if three capacitors C1, C2, C3 are joined in series, then their equivalent capacitance is given by 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. By solving this one, we can find the equivalent value, means C equivalent. And remember this, in series combination of the capacitor, the equivalent capacitance becomes less than the smallest capacitor joined in this combination. Suppose 2 microfarad, 4 microfarad, 6 microfarad are joined in series. So your lowest or smallest capacitance is 2 microfarad. When you will calculate their equivalent capacitance, so that equivalent capacitance will comes less than the 2 microfarad, means the smallest value of the capacitor connected in that combination. So in this way we can find the equivalent capacitance of the capacitor when joined in series. So dear student, today you go through this one, how can we find the equivalent capacitance in series here.